Hey everyone, and welcome to another deep dive. Today we're looking up way up to talk about solar eclipses, and we're going way beyond just the basics. Like think cosmic mechanics and historical interpretations of eclipses.
hmm
Maybe even touch on eclipse chasing a bit. And our main source for all this is this really comprehensive Wikipedia article on solar eclipses. But before we get into all that, I have to ask: have you ever seen a total solar eclipse? You know, that moment when the world goes dark in the middle of the day and the air cools, so you get a quick glimpse of the sun's corona. It's something else.
Yeah, it's an experience that stays with you. I haven't witnessed one myself, but I've spoken to some umbraphiles. Those are the people who chase eclipses all around the globe. Just to stand in the path of the moon's shadow for those few minutes.
Yeah.
Imagine, all that planning and the anticipation, and then the sheer awe when it finally happens. What do you think? Does the idea of becoming an umbraphile intrigue you at all?
Yeah, I could definitely see the appeal. But let's break down the science a little bit.
Yeah.
What's actually happening up there during a solar eclipse? I mean, we all know it's the moon blocking the sun, all right? But that's all it takes. Why don't we have an eclipse every single month?
Yeah, that's where the celestial dance gets a little more complex. You see, it's not just about the moon being between the sun and the earth. The moon's orbit is actually tilted, a little over 5 degrees compared to Earth's orbit around the sun. And it's not a perfect circle either, it's slightly elliptical.
Wait, so if it's just about the alignment, why don't we see an eclipse every month when the moon is between the sun and the earth?
Well, that elliptical orbit plays a key role. It means the distance between the moon and the earth varies. Sometimes it's closer, sometimes further away, and that, combined with that tilted orbit, means that most of the time the moon's shadow misses us.
So it's kind of a lucky cosmic coincidence when everything lines up just right for a total solar eclipse.
Precisely. And because of that, that varying distance between the earth and the moon, we actually get different types of solar eclipses: total, annular, and partial.
Okay, let's unpack those different types. What would those look like if we were watching them?
All right, so picture this. The moon is passing in front of the sun. In a total eclipse, the moon completely covers the sun's disk, and that's when you get that breathtaking view of the corona, the sun's outer atmosphere, blazing around this dark silhouette of the moon. But if the moon is further away in its elliptical orbit, it appears smaller in the sky, and it doesn't quite cover the entire sun, leaving this bright ring of sunlight visible. We call that an annular eclipse.
So instead of complete darkness, you'd see this
Yeah,
ring of fire in the sky.
that's a great way to put it. And then there are partial solar eclipses, where the moon only covers a portion of the sun, almost like it's taking a bite out of it.
So it's all about how much of the sun is covered up depending on the moon's position. But you mentioned earlier that total eclipses are pretty rare. How rare are we talking?
Well, think about this. At any given spot on Earth, a total solar eclipse is only visible roughly once every 360 to 410 years.
Wow, that really puts it into perspective. No wonder those umbraphiles are so dedicated to chasing them down. But here's something I've always wondered about. Could ancient civilizations predict when these eclipses were going to happen? Seems like it would have been pretty mysterious back then.
You might be surprised to learn that ancient civilizations were actually quite skilled at predicting eclipses. The ancient Chinese, for instance, had been tracking the sun and the moon for centuries and could forecast these events with impressive accuracy.
I had no idea. What kind of methods did they use? Was it like some ancient secret or something passed down through generations?
Well, one of their key tools was the Saros cycle. It's this repeating pattern of eclipses that occurs approximately every 18 years and 11 days. Think of it as a cosmic calendar for eclipses, a way to predict future events based on past observations.
So if you know about one eclipse, you can use this Saros cycle to figure out when a similar one will happen, almost 18 years later. That's incredible.
Exactly. But there's a fascinating twist to the Saros cycle. Each Saros cycle eventually comes to an end. Remember how the moon is slowly moving away from Earth? Well over incredibly long periods, that distance increases enough that the moon's shadow no longer reaches us. It's a reminder that even these seemingly eternal cosmic patterns are subject to change over vast stretches of time.
It's incredible to think that something we can explain with simple geometry today was once so mysterious and even terrifying to our ancestors. Now, this Wikipedia article mentions some pretty significant historical eclipses. One that caught my eye is the one that happened on May 29th, 1919. Anything special about that one?
Ah, yes. The 1919 eclipse. It was a pivotal moment for science. It actually played a key role in confirming Einstein's theory of general relativity.
Wait, really? How could an eclipse help prove a theory about gravity?
Well, Einstein's theory proposed that gravity could actually bend light, and the 1919 eclipse provided the perfect opportunity to test that idea. During totality, when the moon completely blocked the sun's light, astronomers were able to observe the positions of stars near the sun.
And what did they find?
They found that the starlight was indeed bent, just as Einstein's theory predicted. It wasn't just any eclipse, it was a chance to test Einstein's then radical theory of general relativity. The idea was that gravity could actually bend light. So during the eclipse, astronomers measured the positions of stars near the sun, and guess what? They found that the starlight was indeed bent, just as Einstein predicted. It was a huge moment for science, a validation of a groundbreaking theory.
That's incredible. So the eclipses haven't just inspired, myths and legends.
Yeah.
They've actually helped to advance our understanding of the universe. But I'm guessing not all historical interpretations of eclipses were so scientific, right?
Definitely not. Before we had the scientific explanations, eclipses were often interpreted as omens or portents, often associated with fear or bad luck.
Right, like those stories about a dragon or a demon devouring the sun.
Exactly. In many ancient cultures, a solar eclipse was seen as a disruption of the natural order, a sign of something amiss.
Okay, that makes sense. I mean, imagine not knowing the science behind it. Suddenly the sun vanishes from the sky. That's got to spark some dramatic storytelling.
Absolutely. And in some cultures, eclipses were seen as bad omens, predicting disaster or even the end of the world.
This article mentions some pretty dramatic reactions to eclipses throughout history. Did some ancient Chinese astronomers get in big trouble for failing to predict one accurately?
Yes, in ancient China, for instance, a solar eclipse was believed to be a sign of displeasure from the heavens, a warning to the emperor that he wasn't ruling justly. And failing to predict such an event could have serious
It
consequences.
sounds like eclipses were a pretty big deal for ancient rulers.
They were. And to appease the gods and ward off any perceived bad luck, they'd perform rituals, make offerings, and sometimes even bang on drums and pots to scare away whatever was devouring the sun.
Wow, those are some pretty elaborate countermeasures. It really highlights how deeply intertwined astronomy and culture were in the past. But as our scientific knowledge grew, did those superstitious beliefs eventually fade?
They did, though not overnight. As astronomers like those in ancient China began to accurately predict eclipses, using tools like the Saros cycle, they became less mysterious and less frightening. People began to understand that these events weren't random acts of the gods, but predictable occurrences based on the movements of celestial bodies.
So knowledge really is power,
Mhm.
even when it comes to overcoming ancient superstitions. But I have a feeling that even though we understand the science behind eclipses today, they still hold a special place in our collective imagination.
You're absolutely right. Eclipses continue to inspire artists, writers, and musicians who find new ways to express the awe and wonder of these events.
That's a good point. Think about, those stunning medieval paintings depicting eclipses,
Right.
or how they're used in literature to symbolize moments of change or revelation.
Exactly. Even as we delve deeper into the science, the cultural meaning of eclipses continues to evolve. It's a reminder that they hold a power that goes beyond, simple explanation.
But we've certainly covered a lot of ground here, from the geometry of the moon's shadow to ancient myths and Einstein's theories. It's amazing to think how much there is to learn about something as seemingly simple as the sun disappearing behind the moon. But I think it's time for us to move on to part 2.
I agree. We've still got plenty more to explore in our solar eclipse deep dive. We'll be back in a flash, so don't go anywhere.
Yeah. Welcome back to our deep dive into all things solar eclipses.
So we've been talking about, how ancient civilizations viewed these events and how even as our scientific understanding has grown, eclipses still have this way of capturing our imaginations. But let's shift gears a bit. You've talked to these dedicated eclipse chasers, the Umbraphiles. Have you ever wondered what it's actually like to experience a total solar eclipse? What would we see and feel and hear if we were actually standing right in the path of totality? It's a truly multi-sensory experience, unlike anything else you'll ever witness. Just imagine, as the moon starts to cover the sun, you'll notice the light around you changing. It becomes this kind of eerie, twilight-like glow, and shadows become incredibly sharp and defined.
I've heard people describe it as feeling almost surreal, like stepping into another world.
Yeah, that's a pretty common sentiment. And as totality approaches, the temperature will drop. You might even feel a cool breeze, as if the air itself is responding to the sudden absence of the sun's heat.
Wow, so it's not just a visual spectacle. It actually affects the environment around you.
Absolutely. And then, the moment everyone's been waiting for arrives totality. The last sliver of sunlight disappears, and the world is plunged into darkness. But instead of being completely black, the sky takes on this deep indigo hue with the sun's corona, that outer atmosphere of superheated plasma. blazing around the silhouette of the moon. It's a sight that's both breathtaking and humbling.
It sounds almost otherworldly. But what about the sounds? Does everything go silent during totality?
Interestingly, no. While some birds might go back to their nests thinking it's nighttime, you'll probably hear a chorus of excited gasps and cheers from the people around you. It's a very communal experience, a shared moment of wonder that connects everyone who's lucky enough to witness it.
So it's this incredible blend of science and nature and human emotion all happening at once.
Precisely. And speaking of science, there are some pretty fascinating phenomena you might observe during totality. Have you ever heard of shadow bands?
Shadow bands, what are those?
Just before and after totality, you might see these wavy lines of light and dark rippling across the ground. They're like ghostly shadows, almost as if the air itself is shimmering.
Wait, so they're caused by the eclipse, affecting the way light passes through the atmosphere.
Exactly. It's a very subtle effect, but if you're looking for it, it can be pretty mesmerizing. And here's another cool thing to look for. During a partial eclipse, if you look at the ground under a tree, you might see hundreds of tiny crescent shapes projected through the gaps in the leaves. It's like the eclipse is creating a natural pinhole camera effect.
Those sound like some amazing details to watch out for.
Yeah.
But let's talk about the main event, the corona. We touched on it earlier, but this Wikipedia article goes into more detail. What exactly is the corona? And why is it only visible during totality?
So the corona is the outermost layer of the sun's atmosphere, a region of incredibly hot, electrically charged gas, what we call plasma, that extends millions of kilometers into space.
Plasma. That sounds pretty intense.
It is. The corona reaches temperatures of millions of degrees Celsius, far hotter than the sun's surface. But it's also incredibly faint compared to the sun's photosphere, the bright disk we normally see.
Ah, so that's why we need a total solar eclipse to see it. The moon blocks out that blinding light from the photosphere, allowing us to see the much fainter corona. It's like turning off the stadium lights so you can see the fireflies.
A perfect analogy. And studying the corona during a total eclipse is incredibly valuable for scientists. It gives them a unique opportunity to observe the sun's magnetic field and learn more about how it interacts with the solar wind.
You mentioned the solar wind earlier. Is that something we need to worry about during a solar eclipse?
Not at all. The solar wind is a constant stream of charged particles flowing from the sun, and it's always present, eclipse or no eclipse. But during totality, the corona becomes this visible tracer of the solar wind's path, helping scientists understand its structure and behavior.
So it's like a scientific bonus. We get this amazing visual spectacle and valuable scientific insights all rolled into one.
Exactly. But there's something important we need to address when it comes to observing a solar eclipse, even during totality. Looking directly at the sun, even when it's partially covered, can cause serious eye damage.
Right, no sneaking peeks. It seems obvious, but it's definitely worth repeating. What about those indirect viewing methods we talked about earlier, like projecting the sun's image onto a piece of paper?
Those methods are completely safe and a great way to experience the eclipse, especially for the partial phases. You can use a pinhole projector, a pair of binoculars with one lens covered, or even a simple colander to create projected images of the eclipse. It's a fun and educational way to share the experience with others, too.
I love that idea. It makes the eclipse into a shared experience.
Yeah.
But all this talk about safety and viewing methods makes me think about all the different ways people have viewed and interpreted eclipses throughout history. It seems like there's a whole cultural side to these events that we haven't really dived into yet.
You're absolutely right. Eclipses have played a significant role in, mythology, folklore, and even art across various cultures for centuries. Do you want to take a journey through time and explore some of those fascinating stories and interpretations?
Let's do it. I'm ready to hear some eclipse tales from around the world. Welcome back to our solar eclipse deep dive. We've been, unpacking the science behind these events, and we even got a glimpse of what it's like to actually stand in the path of totality. But before we wrap up, let's travel back in time and explore how different cultures around the world have interpreted solar eclipses throughout history.
It's amazing to think about how something we can explain with science today was once shrouded in, myth and legend.
Right. I mean, imagine seeing the sun suddenly vanish from the sky.
Yeah.
Without having any idea why. It's no wonder that people came up with some pretty dramatic explanations.
Absolutely. In many ancient cultures, a solar eclipse was seen as this major disruption of the natural order. It was often interpreted as like a celestial battle, or a hungry monster devouring the sun, or even a sign of divine displeasure.
Oh yeah, I've heard those stories, like the one from Norse mythology, where the wolf skull chases the sun across the sky and finally catches it, causing an eclipse.
Exactly. And in some cultures, eclipses were seen as these powerful omens. For example, in ancient China, a solar eclipse was believed to be a warning from the heavens, a sign that the emperor wasn't ruling justly.
It's like a cosmic message from the gods, letting the emperor know they weren't happy with his performance.
Precisely. And to appease the gods and ward off any perceived bad luck, people would perform these elaborate rituals and make offerings. And sometimes they would even make a lot of noise, like banging on drums and pots, to try to scare away whatever was thought to be, attacking the sun.
It sounds like they took their eclipse countermeasures pretty seriously. But as our scientific understanding of the universe grew, did those superstitious beliefs start to fade away?
They did, but it was a gradual process. As astronomers began to accurately predict eclipses, they lost some of their mystery and their power to frighten. People began to understand that these weren't, random events caused by angry gods or hungry monsters, but predictable occurrences based on the movements of celestial bodies.
So it seems like knowledge really is power, even when it comes to overcoming ancient superstitions. But even though we've demystified eclipses through science, they haven't lost their ability to inspire us, have they?
Not at all. Just think about all the countless works of art, literature, and music that have been inspired by solar eclipses. They continue to captivate our imaginations and remind us of the beauty and the vastness of the cosmos.
Yeah, I'm thinking of those incredible medieval paintings that depict eclipses, often with, religious or symbolic overtones. And in literature, eclipses are often used to symbolize moments of great change or upheaval.
Exactly. Even in modern times, solar eclipses retain this special place in our collective imagination. They're a chance for us to connect with something larger than ourselves, to marvel at the, intricate workings of the universe, and to remember that we're all part of something truly extraordinary.
Well said. I think that's a perfect note to end our solar eclipse deep dive on. We've journeyed from the basic science of how these events occur, to the ancient myths and legends that surrounded them, to the modern-day awe and wonder they continue to inspire.
It's been quite a journey.
It has. So the next time you have the opportunity to witness a solar eclipse, remember all that we've talked about. Make sure you use proper eye protection, of course. But also take a moment to appreciate the science behind it and the history of human fascination with these events, and that profound sense of wonder they evoke. And who knows, maybe you'll even be inspired to create your own eclipse story or artwork to share with the world.
Until next time, keep looking up and keep exploring the wonders of the universe.